with you with another session for problem solving for standard 11, and it is unit and dimension section. We will see here some conceptual problems that need some key concepts to solve the problem. Problem solving is not that you are given some data and you are inputting it in the formula and you are getting the answer. Whenever you are solving problems or the problems that are asked in the competitive exams like JEE, they require that you should know some key concepts to solve this problem. And if you know these key concepts, your work becomes less difficult, it is more simple, and you can solve the problem in very less time. Just you have to apply the key concepts. So let us start our discussion, and before starting the discussion I will request you to please subscribe the channel. Please help me, help a teacher, and you will get study materials from my side. So let us start our discussion. So this question is asking, if this is a sine omega t minus kx, which is the simple harmonic motion, you are given this equation and you need to find the dimension of omega and k. Omega and k, these dimensions have to be found. Now what I have seen during my teaching, whenever I give such questions, what the student do? The student takes the approach which is conventional, that he is equating the dimension of left hand side and equating the dimension of right hand side, and then landing into a complex situation, and he is not able to solve the problem, or even if he is solving, it is wrong. The key concept that you should use here, that trigonometric ratios are dimensionless. Trigonometric ratios are dimensionless. They do not have any dimension. Sine, cosine, tangent, cotangent, secant, cosecant, they are dimensionless. They don't have dimension. So this quantity that is inside the bracket, it is a sine quantity. This is sine, that means this is some angle. So this quantity overall has no dimensions. Omega t minus kx, overall quantity is dimensionless. Don't think that omega t is dimensionless. Dimensionless. Now whenever you have said this type of a quantity which is dimensionless, it means omega t and kx have same dimension. Have same dimension. This is the concept that you have to use. Not the whole thing that you are equating the dimension of this quantity of mass, length, time, and equating with the dimensions of mass, length, and time on the left hand side and then finding out those values. It is a tedious process. You do not require it. So what we do, omega t kx. Now there are two situations, if you know k and if you do not know k. K is 2 pi by lambda. It is called wave number. So the dimension of k is L inverse. 2 pi is a number, it has no dimension. Now what you have to do, omega t, it has dimensions of time, k is L inverse, and x is displacement, so it is L. So overall power of L on the right hand side is 0, it is equal to 1. So omega t is equal to 1. So omega, dimension of omega is t inverse. This is you can solve this in a simple step. There is no need to evaluate the dimensions on the left and right hand side. Just use this concept that the quantities that are sine, cosine, or trigonometric ratios, they are dimensionless. This is how you can solve this problem. And it is, you can see it is 2 or 3 line problem. Or maybe it is 1 line if you apply the right concept at the right time. So this is how we can do this. Now suppose if you don't know what is 2 pi by lambda, suppose you don't know, you haven't studied that k is 2 pi by lambda, then you can use the concept that I am sure you know that omega is 2 pi by t. Omega is 2 pi by t. You can use this concept. So on the left hand side, what you have, 2 pi by t into t. You don't know what is k, dimension of k, and it is L. So t cancel. 2 pi is dimensionless. It has no dimension. It is a number. So k is again 1 by L. So it is L inverse. And here also the dimension of k is L inverse 2 pi by lambda. So again I am repeating that you have to remember these two key concepts. That trigonometric ratios are dimensionless. So you don't need to check the dimension of y on the left hand side and dimension of a on the right hand side and find omega, t, k, x. Don't make the things complex. Keep them simple. So I hope you have understood this. Now we have a very important question here, which is conceptual again, because I am not going to discuss with you the conventional questions that are given in the books. This is from exemplar series. Now you have to give an example of a quantity that has unit but no dimension. I asked this question in the Viva and the student, and it is very strange to say that it was a BSc student who could not answer this question. I don't know why he could not answer the question. Physical quantity that has unit but no dimension. It can be measured. Physical quantity is something which you can measure by instrument. It has a unit but no dimension, and the best example I have shown you here. I have given the hint here, that is called angle. Angle is arc length upon radius. Upon radius. You measure angle in degree, in radian, whatever, it has units. But it has no dimension because it is a ratio. The quantities that are ratios have no dimension. This is one theory, but I am going to show that this theory is not always true. Ratio has no dimension, and I will put a exclamation mark here or a question mark, whether it is always applicable or not. Now let us see. In the problem B, the physical quantity, it has neither unit nor dimension. Now you know that numbers, they have no dimension, no unit, 1, 2, 3, 4, 5. But it is, since it is a physical quantity, it can be measured. What is that quantity? Any ratio like refractive index mu sin I by sin R. Refractive index of water is approximately 1.33. It is a ratio. It has no unit, no dimension. Relative permittivity. Relative permittivity. You will study in dielectric, epsilon R. Relative density. Because whenever you are using this relative, it is in comparison, or it is a ratio of one quantity with the other. C, a constant which has a unit. A constant which has a unit. There are many such constants. You just need to concentrate and think for a few seconds, what is this constant that has a unit? And that constant, the best known constant, is gravitational constant. We say it is the gravitational constant. It has unit. Then you have another quantity that is called dielectric constant. Their names are constant. They contain the word constant, but they have unit. They are not simple numbers. A constant which has no unit. Fourth, the example is Reynolds number. Reynolds number, and you encounter this thing in fluid dynamics. The Reynolds number tells whether your flow is turbulent or it is a streamlined flow. It is a constant, but it is a number, but it has no unit, and this number is very important. This number describes a physical situation, what type of flow it is. Now let us come to the next question, which is relatively simple, and I think you have done this. You can do this question, or you have done such questions, that the maximum height of a mountain on earth, it is limited by the rock flowing under the enormous weight above. Studies show that the maximum height depends on Young's modulus. Some part of the questions are not clearly visible, sorry for that. Young's modulus of the rock, or it is rod, it should be rock, acceleration due to gravity, and density of the rock. So what we do, we write this height is proportional to Young's modulus to the power A, acceleration due to gravity to the power B, and density to the power C. To remove this proportionality, we put a constant y to the power A, g to the power B, rho to the power C, and the next process is simple. You have to use the principle of homogeneity of dimensions, that left and right hand sides, homogeneity of dimension, that left and right hand side should have same dimension. So this is height, it has a dimension of length. So on the left hand side, LHS, the dimension is L. Now let us see what is this. So you have Young's modulus, which is force per unit area by change in length by original length. This is the formula for Young's modulus. Now what you have to do, so first write the dimensional formula for y. Force means LT to the power minus 2 into m, mass into acceleration, so it is mLT to the power minus 2 by L square, and again you have this change in length by length, so it is both, this is again a ratio, so dimensionless, so it is ml minus 1 to t to the power minus 2. Acceleration due to gravity, it is lt to the power minus 2, and density also, it is very simple, ml to the power minus 3. Now let us start our equation, writing the equation. On the right hand side, what you have, y to the power a means ml minus 1 t to the power minus 2 to the power a, lt to the power minus 2 to the power b, and ml minus 3 to the power minus 3 is c. Now let us equate the quantities, the powers of mlt on both sides. On left hand side, the power of L is 1, so it is equal to 1. Now it is minus A plus B minus 3C equal to 1. The dimension of mass, this is for length. Now let us equate the dimension of mass. It is A plus C equal to 0, because you don't have any mass on the left hand side. So this is equation number 1, this is equation number 2, and then equate the dimensions of time. It is minus 2a minus 2b equal to 0, because again there is no time in the left hand side. So here we find a equal to b and a equal to minus c. Now you can put these equations in the above equations, in this equation. So what you have, a equal to minus c, so this will be c. A equal to b and a is equal to minus c, so again this is c, and this is minus 3c. So it is C is equal to minus 1 by 3. So A is equal to 1 by 3 and B is equal to 1 by 3. So you have found the quantities, and you can now write the formula. How does this vary with H is equal to some constant K, A to the power 1 by 3, 1 by 3 into G into rho. This is the formula that you require. So using the principle of homogeneity of equations, you can find out the relation. Now the next question, this is again from the dimension analysis, but the question is asking something which is not very usual. It is asking that the maximum mass m1 of a boulder that is swept along by a river, it depends on speed of the river and the acceleration due to gravity and the density d of the boulder. Calculate the maximum change in maximum mass of the boulder that can be swept by the river when the speed changes by 1%. Now to answer this question, you need to find a relation between the mass of the boulder and the speed of the river V, acceleration due to gravity G, and again density rho. So again we will use the same concept. M, dimension of M, here it is M, it is K, V L T to the power minus 1 to the power A, L T to the power minus 2 to the power B, and M L to the power minus 3 to the power C. Equate the coefficients. Let us take AL first, length. So it is A plus B minus 3C equal to 0 because there is no length here. This is equation number 1. Then you take time. This is for L. For time you have minus A minus 2B equal to 0 because there is no time. 3. And for mass on the right hand side you have C equal to 1. So if you have found what is C, you can put this in equation number 1. So it is A plus B is equal to 3 and minus A minus 2B equal to 0. Add them. It is minus B equal to 3 and B equal to minus 3. If B is equal to minus 3, you can put this here, minus A plus 6 equal to 0, A equal to 6. So you have found A, B and C. So our formula for mass, it is some constant K, V to the power A means velocity to the power 6, acceleration due to gravity to the power minus 3, and density rho is equal to the power C, which is equal to 1. So this is our formula. Now what is being asked, that if the speed changes by 1%, what will be the change in mass? So you can calculate this. Since mass is varying by, so it is, speed is to the power 6, so del m by m into 100, it is 6 times. It is similar to error analysis. It is 1 by 100. It is 1 by 100. So when there is a change in mass, when there is a change in speed by 1%, your mass changes by 6%. This is a combination of error analysis and dimensional analysis. Now the next question is, the maximum height of a mountain on earth, it is, I have discussed this question. So this is how you can do the questions, you can solve the problems. Now let me introduce you to a very important quantity in dimensional analysis, and it is very interesting. Interesting in the sense that suppose You have work. Work is force into displacement. It is a dot product and its dimension is mlt to the power minus 2 into L. So it is ml square t to the power minus 2. Then you have another quantity, torque. It is r cross f, but if we write the dimension, it is L into ml t to the power minus 2. Again it is ml square t to the power minus 2. They both have same dimensions, but the quantities, physical quantities are different. One is work, which is a scalar product, torque, which is a vector product. Such quantities are called isodimensional quantities. Isodimensional quantities. They have same dimensions, but physically they are different. Same dimension, but physically different. Physically different. Physically they are different. Work is a scalar product. Work is F dot D, and torque, the rotating action of force, is R cross F. One is a scalar product, physically different, and this is torque, this is vector product. Physically they are different quantities, but they have same dimension. They are called isodimensional quantities. So I hope you have understood how to approach the problem and how to solve the problem. Now let me show you another objective problem that was asked in the JEE exam some time back. It was in 2006. And this problem I am discussing with a special purpose that you do not need to do any calculation to solve this problem. You have to remember the concept. See, a student performs an experiment for determination of acceleration due to gravity, and what he finds that L equal to 1 meter, and he commits an error of del L. He measures, he makes some personal mistake for del L, measuring the length. Now when he is measuring time with the help of a stopwatch that has a least count del T, and again he commits some mistake, and his human error is 0.1 second. Now for which of the following data the measurement of G will be most accurate? You will be confused how to do the calculation, what calculations are necessary. But remember this concept that the measurement with the smallest unit, and the smallest digit after decimal, it is going to provide you the most accurate reading. Option D is the correct answer. The key concept is smallest unit reading with, see the unit again, here is point, it is point decimal, with smallest unit or smallest digit after decimal is the most accurate measurement. After decimal is most accurate. So option D has 1 mm, smallest unit and smallest amount of measurement is done here. All these units are all the measurements, although they are in unit 5 mm. But this one is 1 mm. If he is measuring 1 mm, the smallest reading he is taking, it is the most accurate reading in spite of the mistakes that he has made. He is measuring 0.1 second. So, and his error is 0.1 second. So this error is this uncertainty is reflected here. And it is 50.1 mm. 50.1 mm. Here also you have 0.1 after decimal, but the length is 5 mm. So this is the most accurate measurement that he is doing. You have to use this key concept. So I hope these problems will help you, and if you have any question, then ask me in the comment section. And please do subscribe the channel. Thank you.